Hello and welcome to another episode of Our Own Devices. We are going to talk about a subject, and I can tell you with a lot of conviction that we are going to talk about a subject I have no clue about. Okay, and that's why we are doing it because it doesn't usually happen that I get something in my inbox that I have not heard of, especially in the space of technology, and that immediately triggers my curiosity. And we are going to talk about something really new, and that is the concept of FPGAs. And to to discuss this new topic with us is AMD's Sanjay Churiwala. So, Sanjay, welcome to the show.
Thanks, Nandagopal, for inviting me to this event, right? We'll try to make sure that by the end of this 20, 30 minutes, you are very familiar with what FPGA is.
Yes. So usually how our podcast work is at the end of it, you have learned something new, or you have at least started thinking in a different direction because yeah, we have nudged you to see something new. Okay, that's the concept. So I think from this perspective, the topic works very well. So
Yeah, and
let me
I'm
just put you
also
in the
very
hot
sure
seat.
by the end of it, right? I will also be someone who would have ended up learning something, a very different
Yeah.
perspective around our own products also.
Sure. So let me just put you in the hot seat by asking you what are FPGAs? So how would you define them like simply, how do you explain that to a regular person?
Yeah. So FPGA stands for Field Programmable Gate Array. Okay. So the important aspect of FPGA is field programmable. What that means is you can have a chip and you can change its functionality whenever you want without coming back to the chip manufacturer. Okay. So that's why we
Okay.
call it field programmable. So look at it this way. Last 3 years or so, somehow chips, semiconductor, IC is something that everybody has started knowing. Okay. If you look at it, a computer chip, you computer processor chip, you cannot use that processor chip inside your, say, digital watch. Or the chip that is
Hmm.
used in your digital watch, you cannot use that in your smart TV. Each of these has its own chips.
Yeah.
While FPGAs are chips or ICs where you can change its functionality. So the same IC today, you can use it inside your computer. Tomorrow, for whatever reason, you want to take it out, put it somewhere else. That's what you can do it. Now, let me make it a bit more simpler. Okay. Uh, think of something like a Lego set, Lego block set, right? When you buy a Lego
Yeah.
set, you get multiple pieces of various shapes, basic shapes,
Yeah.
right?
Yeah.
And then you can combine them whichever way to create a different toy each time. So similarly, in an FPGA device, we will have basic electronic elements and we can arrange them differently. So you'll have lots of, say, flip-flops, you'll have lots of memories, we'll have lots of DSPs, and we can arrange the connectivity between them differently, right? And so that's why
Yeah.
it is field programmable. Each time you get a new hardware depending on what you wanted. So that is the basic fundamental concept of FPGA.
If I can just ask you a very simple question that came to my mind, and you gave a very good example, right, of the smartwatch or the TV. So when we are talking about building our own chips in India, we know, for instance, that we have been building chips for certain types of things over many decades, but not for a computer or those kind of things. So how does that cost thing work out? So let's say the same chip can be used in a smartwatch as well as a high-end laptop,
Right,
but then from a smartwatch perspective, it is over delivering, right? So
right.
your cost doesn't make sense, right? You're putting a
Yeah,
very expensive thing in a place where it doesn't need. So how does that work? So is it about scaling down or scaling up?
yeah. So it's an interesting point, right? What I said was to explain the concept how the same chip can have different functionalities, right? Like you
Yeah, yeah,
said, no smartwatch will use FPGA. Okay, because of the same thing,
yeah.
because the exact same
Yes.
reason that you mentioned. So if I extend your question slightly, okay, let me explain
Hmm.
where can we use FPGA, right?
Yeah, yeah.
So in a chip design process, the chip design manufacturing process is a very costly process. Okay.
Yeah.
And because the cost of failure on a chip design is very high, it is cost is very high in terms of the dollars spent, and it's also high
Hmm.
because once your chip comes and it is not working well, if it's not working well, you have to go and redo. By the time your revised version comes in, you may have lost the market. Okay.
Mhm.
To the extent that the process of chip design, the getting it right the first time is so important that around 70% of the chip design process is spent only in verification. Okay.
Okay.
Now, this provides one use case, and we'll cover some other use cases also. So think of it that you are going to come up with a very complex chip for your next whatever, right? Next smart TV. Okay. You want to verify that chip. So you can implement that chip on an FPGA and then you verify it.
Okay.
Because if that design is incorrect, you have not wasted a lot of hardware resource, right? You can debug, fix, re-implement, verify. Debug, fix, re-implement, verify. Once you are confident, then you will go in for the actual high volume chip design for your smart TV. Right? So this is one application,
Okay.
one very popular application, right? And we call this application as a prototyping, right? Because on an
Mm.
FPGA you can keep doing it again and again. Let's look at another good application. This is used often on the industrial scale. So imagine an industry which is evolving very fast. Okay. So by the time you implement something, the industry has moved forward, standard has moved, new algorithm has come in, new technique has come in. Okay. So your chip, you put in so much effort and then it has to be updated again. Versus an FPGA, it is much more easier to to update. Now think of examples like automotive industry, vehicle industry, automotive industry. This is going through a major inflection point. Okay. You do not know tomorrow, like in a year, what else could change. Sometime back, electric vehicle, hybrid, all those kind of things are changing, right? We are talking about software defined vehicles. So this is again where FPGA kind of devices will be very useful because you can keep pace with the standard. Okay, there are companies which claim that, okay, we are tracking the standard up to a week. So that can happen only when they have something which they can quickly update. Now, think of other applications since you mentioned earlier that, okay, this is focused more on AI side of things, ML side of things, right?
Yeah.
AI, every day there's a new algorithm, new technique. Okay. If you
Mhm. Mhm.
come up with a dedicated chip, by the time you come up with a dedicated chip, again, the whole technique has moved, right? So again,
Yeah.
FPGA will allow you to reconfigure it to the latest technology immediately, right? So now let's extend this still further, right? We talked about areas where the industry is evolving. Okay, let's look at things where the shelf life is very long. Okay, you
Mm.
created a product, you sent the product out, and now the product will be alive for 10 years. Okay. Think of your car. You buy a car, the car is with
Yeah.
you for
Yeah.
10 years. You sent a satellite up into the space, the satellite is there for more than a decade.
Yeah.
In between, again, technology has evolved. Okay. A satellite which was sent onto the orbit 5 years back, you want it to have the latest AI technique, latest AI network. Okay. With FPGA, it is possible. You can update your hardware into the space from here to make use of the latest techniques, right? So since you are talking about cost perspective, right? So that's what I was trying to explain that these are the various use cases. I
Yeah.
used smartwatch just as an
Yes.
example, like you rightly said,
Yeah.
using an FPGA in smartwatch is a major overkill, but it is
Mhm.
possible that the smartwatch manufacturer was using an FPGA to validate their design before they went into volume production of the smartwatch.
Yes. Yeah.
Right?
Yeah. Yeah. So in a way, if I'm right, if I simplify it or maybe oversimplify it a little bit, it's like an OTT update at the chip level.
OTT update at the chip level is fair, right? You can call it
Right?
OTT. We also use over the air, right? Because
Okay.
you may
Yeah.
not
Yeah.
necessarily need a physical connectivity
Yes. Yes.
also,
Yes.
right?
Yeah. Yeah. Yeah.
So OTT is one. Uh, the other kind of things which may happen is, for example, there is a sudden demand which comes in, right?
Mhm.
So by the time you create a dedicated hardware for it, that demand may go away. So
Yeah.
once
Yeah.
again, you have an FPGA, and then a very clear example of that was cryptocurrency, right? So if you talk about OTT, right?
Mhm. Yes. Yes.
Cryptocurrency
Which
had
was
peak, right? And
yeah. It was
for crypto,
overclocking also, right? At the chip level, it was overclocking your entire built-in capabilities.
right? So you need to do overclocking because you want to do a very fast processing.
Yeah.
That's why you're doing, right? So
Yes. yeah,
The processors there were not built for crypto mining, but then FPGAs
yeah,
come
yeah,
into picture exactly for that purpose,
yeah,
right? You take it in,
yeah,
do it your
yeah.
do your exact immediate purpose.
Mhm.
There's one more interesting thing, right? Again, talking purely from cost perspective,
Yeah.
in the context of Indian education system. So this is not a very big business for
Mhm.
us, but
Mhm.
we talk about chip, and then you also hear about a lot of university students talking about how universities, they cannot have the capability to fabricate, right? If they have learned something in electronics,
Yeah,
they
yeah,
cannot fabricate. So MIT is actually encouraging a lot of universities to buy FPGAs. You have learned something in electronics, you want to implement to see what works, what does not work. Okay. So FPGAs are good. You implement it. If it works, great. If it doesn't work, you re-implement after fixing. After that, your next batch can also implement the same device versus if you had gone in for the actual fabrication, that is very costly. So it's also saving a lot of cost, right? Not just into
okay,
the product that you students can get their experience on the actual hardware without going in for the fabrication using FPGA. So I thought of giving some examples, right, to contrast that with smart watch example where you don't necessarily use it
yeah,
directly inside the device.
yes, yes. If I can ask you from an AMD perspective, again, I might be wrong here because when you talk about AMD, like people understand that you have the Ryzen range of processors, right? But is it technically possible that instead of having different versions of it as you have now, you have one Ryzen processor which can scale up to the top end as well as be on at the bottom end of a use case, right? So, and again, you configure it according to the requirement, and instead of creating three new SK, as in three or four SKUs as you have now.
So technically what you said is 100% possible. Okay. But practically it is not possible. Think of it this way.
Hmm.
Okay. You want to buy a Lego box. Okay. Uh,
Yeah.
if you want to make a very small house, okay, why do you want
Hmm.
to buy a box which is a much bigger set? Okay.
Yeah, for a Star
If you
Wars
right,
kind of.
if you
No.
want to buy if you want to make a bigger house with that Lego block, right? Then it made
Yeah.
sense. But no
Hmm.
point buying a large block Lego box when you only because you may make a small processor or make a large processor, right? So if you
Yeah.
want a processor with lesser capability, specific something, right? If you know, then you might as well build a processor just for that purpose. Okay. So the
Hmm.
other way to look at it, right? Processors are more like consumer product segments where you get mass volume.
Yeah.
So you might as well do the mass volume for that item, right?
Hmm.
A lot of examples that I mentioned, right? There either shelf life was important, long shelf life, right? Or
Hmm.
low volume. Okay.
Yeah.
Prototyping, low volume. Low volume prototyping for a mass volume production. Okay. Uh,
Hmm. Hmm.
Large shelf life. Processor, they will have life of what, 3 years, 4 years, 5 years, right? So you don't necessarily
Yeah.
need
Yeah.
that kind of thing. So technically, yes,
Yes.
capable. You have one FPGA which you can program for
Mhm.
low-end processor, program for high-end processor. Practically, not that won't be a good
Yeah.
use model.
Yeah. Now, the other question I want to ask you is again in the Indian context because we are talking about setting, building our own chips and having that setup. And I know that is a very difficult conversation, right? Like, you have a conversation with the chip manufacturer at that level itself. They have to figure out that what kind of investment is going to go into the configuration that you have wanted.
Right.
Does having an FPGA kind of a lineup, does that simplify that process? Does it make it cheaper to think about how to scaling up on your production part of EA? Because does it give you a little bit of leverage in that sense?
Not necessarily in the manufacturing of the chip per se. Okay.
Chip itself. Okay.
But the system level design is where what you said exactly helps. Okay. If you are doing a
Okay.
system
Okay.
level design, then you can use an FPGA because if there are changes that you want to make, you can make those changes and go on.
Hmm.
Okay. Chip manufacturing itself, it will not be again very useful. Uh,
Useful. Okay.
yeah. Again, chip verification, yes, but the manufacturing process is very, very different. Okay, AMD, we ourselves, right? Within AMD, we don't do our own manufacturing also, right? Because that process is very,
Yeah.
very
Yeah.
different. Like you said, a different
Yes.
conversation, difficult. So manufacturing, no, but yes, the system design portion, yes. You'll find a lot of system design
Yeah.
houses using our chips, the FPGA chips.
Okay. Okay. Now, when we talk about AMD itself, so is this now something that is unique to AMD, or are you seeing the industry also gradually move towards this kind of a thinking?
The FPGA style, right? So
Yeah.
there are two major FPGA companies in the world. Okay. One
Hmm.
is us, and the other is a company called Altera, okay, which was
Yeah.
earlier owned by Intel. Now, there's
Hmm.
obviously interest in FPGA from other manufacturers also. There have been many manufacturers who have come in the past and then they have faded away.
Yeah.
You notice one interesting thing that I mentioned. The reason why they fade away is not because of lack of market, okay, because we
Hmm.
said we support products. This is very useful for products with a long life cycle. Okay. You will
Yeah.
see when you buy your cell phone in 3 years, you change it. Okay. When you buy your
Yeah.
laptop, we said in 5 years, you change it. Okay.
Hmm. Hmm.
Electronic components are not used to being there for 15 years, 10 years. Okay. One
Yeah.
of our
It's
major
not a good
market,
business model, also, right?
yeah. So one of our major markets is we are saying our products you can keep on reconfiguring many number of times for many years. Okay.
Hmm. Okay.
So for other competitors to come in, they need to have that kind of quality processes built in where they can
Okay.
ensure and guarantee that the product will be there for you to reconfigure, right? I mean, 10 years later, the product should be working in a
Hmm.
good working order
Yeah.
so that you can reconfigure.
Yeah.
Assuming tomorrow you come up with such a product, okay, just imagine, right? Tomorrow you come up with
Hmm.
such a
Hmm.
product where you are willing to guarantee that the product will be there for 10 years. Okay. Do you think a space agency would be willing to take your product? They want to wait
Hmm.
for 10 years to see whether your product actually is alive for 10 years or not, right?
Yeah.
After
Yeah.
10 years, they will buy your product,
Yes. Yes.
right? So then being able to come up with that kind of rigorous quality process, the design, the manufacturing, and being able to
Hmm.
stand by that guarantee, which your customers are also willing to accept, right? That is one barrier. But again, at this time, there are two major players, us and Altera. These two are major
Yeah. Yeah.
players, right?
If you're talking to, let's say, engineering students, like, what kind of is this a new opportunity that is opening up for them to, to acquire a new skill to cater to this up and coming kind of a market?
If an engineering student wants to come into say FPGA kind of career, so for students of electrical, electronics, and computer science, this is a very good career option. Yeah.
Yeah.
Like I said, IC design, chip design, etc., has become much more popular and well known in last few years. Most of the tier one engineering colleges, like if you talk about IITs, the better known NITs, the BITS kind of colleges, they have been aware of FPGA
Hmm.
for a while because they have been using FPGAs for a while. Okay.
Yeah.
The
Yeah.
tier two colleges, 100 plus colleges, is where this knowledge is now uh, percolating,
Percolating, in a way.
percolating now,
Yeah.
right? So if somebody thinks that okay, we want to get into this area, then first is the degree in electronics, communication, electrical, computer science, that kind of thing. Second is a knowledge of aspects of VLSI design. Okay, without worrying about FPGA or IC, just
Hmm.
aspects of
Hmm.
VLSI design. That could be, say, RTL design, digital circuit design, timing analysis, hardware description language like Verilog, VHDL. Now, obviously, not everybody will understand everything, but some elements of whatever, right?
Yeah.
Or somebody could think of making a career on FPGA tools. That would mean knowledge of C, C++, data structures, algorithms. Or somebody could decide to work on, say, domain knowledge. I want to use FPGA for let's say communication equipment, right? So I need to develop the communication
Yeah.
domain knowledge. I want to develop the know about the AI algorithms, right? So the good thing is that there may not be necessarily something very unique that we have to learn. The IC design process or ASIC design process was a good start point for somebody to come. Or tools, anybody who's familiar with ASIC design process, IC design process, they can come into this industry very easily. Those same kind of skills might be applicable, right?
Hmm.
When we talk about soft skills, again, similar to these multinational IC design companies, you have to work across teams, across time zones, be sensitive to other person's time, be a bit flexible, like cross geographical, cultural aspects, and all those things. The other interesting thing happens is this industry evolves very fast. Okay. And our customer base, like I said, right, that our customer base is those who are the standards and the algorithms are changing very fast. So our customer base evolves much faster than us. Okay. So this attitude of lifelong learning, right? So those are the kind of things that we should. So if you look at it, very very generic kind of skills in terms of soft skills, and in terms of technical skills similar to ASIC design or IC design style, that should be good enough for us to somebody to find a career in FPGA industry.
If I come to my last question, Sanjay, it's like so you're talking about a new opportunity in the hardware side. Now, are you seeing that because this new opportunity is developing and and it's creating a lot of new use cases? Do you think that companies which are not essentially working on this side, but is it going to change the way companies think about their possibilities, right? Because this technology is available, which is reconfigurable in the future and that kind of thing. Are you going to think out of the box on the kind of products you would make maybe on the software side, right? Is that
Yeah.
kind of a thinking already happening?
So you mentioned that you're familiar with Ryzen, right?
Yeah, yeah.
So Ryzen, we have a new series of device called Ryzen AI. I don't know if it has caught
Yes,
your
yeah,
attention.
yes, yeah, yeah, yes, yes.
So a part of Ryzen AI has some extract of one slice. Think of it, one slice of FPGA has gone
Okay,
onto Ryzen AI. Okay. So
okay,
I'm just
okay.
giving you a feel,
Yes,
right? That
yes,
okay, within
yeah, yeah.
within our company, this has
Mhm.
happened, right? That one of our
Okay,
slice of FPGA went onto the Ryzen AI. Okay.
yeah.
And the logic is again simple. It provides high performance compute. That slice is providing high
Mhm.
performance compute, which you can
Yeah,
reconfigure, right?
reconfigure. Yeah.
AI is
So
something
in
which
a
will
way, the
just
upper limit of what that high performance compute is can keep changing, right? In a way, is
the
that right?
so upper limit not in terms of clock frequency, but upper limit in
Yeah,
terms of the network. Tomorrow
network.
there's a
Okay.
new tomorrow there is a new network which gets published, which is more efficient. Okay.
Yeah,
So
yeah,
on
yeah.
that Ryzen AI, we can implement that network immediately. We here
Plug and
is
play
not
kind of a thing. Yeah,
we here is not even AMD. AMD has sent that
yeah.
Ryzen AI to your home.
Yes,
You
yes.
can
Yeah,
implement that, right?
yeah.
The
Got it.
application that is running on your computer, that application implement a new network without coming to me. Okay.
Yeah, yeah,
So some of that element, like you said, right, we are already seeing at least one practical application in terms of Ryzen AI.
yeah, yeah,
For
yeah.
any other company to reach there, either they have to enter into some kind of licensing understanding with us, right?
Hmm. Hmm.
Or they have to develop this capability themselves.
Yeah. Interesting. So absolutely fascinating. So I get a sense that we are talking about something like AI, right? Because AI, we don't know what's going to happen tomorrow because the way it is structured, it's opening up new possibilities on a real time basis, right? As you
Exactly.
use it more, you
Yeah.
keep understanding. Okay, you can do this also. You can do this also. Let me try something else. So I think it has it's that AI kind of a uptake happening, but at the hardware side. If am
It
I
is on
right
the
in saying
hard.
that?
It is on the hardware side and something that you can keep evolving. Okay. This
Yeah,
technique, by
yeah,
the way, technology is relatively old, 1980, right? So FPGA technology,
yes,
when it first came, it in the early 80s or 1980, something of that kind, right?
hmm.
Just that depending on the different market segment, our products have also started evolving, right? We talked about
Yeah,
basic building blocks, right? What kind
yeah,
of building blocks do we put in? So we
hmm.
have also started now calling our products as adaptive SOC, right? Not
Hmm.
just FPGA, adaptive SOC.
Yeah,
Adaptive is to indicate
SOC,
adaptive,
yeah,
and
yeah,
SOC to
yeah,
indicate that our building blocks have started including, say, high bandwidth memory, for example. Yeah.
yes, yeah,
Specific circuits for parallel processing. So we are
yeah,
started calling that as the mix of elements has become much broader. So we call it
hmm.
SOC and it's adaptive. So that's the new name.
Yeah.
Right? So that's what it is, kind of.
Absolutely exciting. So on this very exciting note, I think we'll call it a day. So thanks for being on the show.
So, yeah, thanks, Nandagopal, and hopefully your audience likes it. Right? I'll also look forward
I'm
to.
sure this is going to be like, again, it's completely opening up your mind in a way, blowing your mind on what is possible, especially if you have a little bit of that scientific thinking happening. I'm sure a lot of youngsters, a lot of seniors who are already in the industry will be excited by the opportunities this opens up. So again, thanks for being on the show.
Yeah, and thanks for giving us the opportunity. Like you as senior journalist like you is not familiar. I'm sure many more people are not familiar, right? So we probably get
Yes,
this
I hope
opportunity to
so. I hope
share
so.
about these techniques,
Yeah.
this technology with many other people also, right? Okay.
Yes.
Right.
Yes.
Thanks.
You were listening to Our Own Devices. We'll be back again next week with another guest, a lot more insight and knowledge. Till then, we are available everywhere you listen to your pods.